In this video, we will practice using the first fundamental theorem of calculus to solve real-world problems. This is a calculator active problem, so we will be using our graphing calculator as needed. The first fundamental theorem of calculus says that the end value is equal to the initial value plus the net change in value. The net change in value is given by the integral of the rate. When a certain grocery store opens, it has 50 packs of toilet paper on the shelves. Customers remove toilet paper from the display at a rate modeled by f of t, for t within 0 to 12, where f at t is measured in packages per hour and t is the number of hours after the store opens. After the store has been open for 3 hours, store employees add packages of toilet paper to the shelves at a rate modeled by g of t, for t on the interval from 3 to 12. Problem number 1. How many packages of toilet paper are removed from the display table during the first 2 hours the store is open? Round to the nearest whole number. If you integrate a rate, it gives you the net change in amount. And we want to know how many packages of toilet paper are removed. So we need to integrate the rate at which toilet paper is removed, which is f at t. Since we want to know how many packages were removed during the first 2 hours the store is open, we will integrate from 0 to 2. Let's type f of t into the calculator. Hit the y equals button. On a problem like this, we have a rate in and a rate out. I always like to put the rate out on y2. It helps me to keep track of what I'm dealing with. So the rate out is 10 plus 0.8t. So here we go, 10 plus 0.8t. Obviously I'm going to use x instead of t. And then we have the sine of t cubed divided by 100. So sine of x cubed divided by 100. I recommend that you make a little note to yourself that you put f of t into y2. So we need to integrate f of t from 0 to 2. Back to the calculator. Let's quit our way out of here. And to integrate, you hit math, and then you choose option number 9. We are integrating from 0 to 2. And we want to integrate f at t, which we just put into y2. To access y2, hit the vars button, switch over to the y vars menu, hit enter for option number 1, and choose y2. And don't forget the dx. So there it is, 20.051. Approximately 20 packages of toilet paper are removed from the display during the first 2 hours that the store is open. Problem number 2. Find f prime at 7. Using correct units, explain the meaning of this value in the context of the problem. Keep in mind that we typed f of t into y2 on the calculator. Let me show you how to evaluate f prime at 7. So for the derivative, you hit the math button and choose 8. So we want to take the derivative, so d dx of f of t, which is y2. So hit the vars button, switch over to y vars, choose option number 1, and y2 is f at t. So we're taking the derivative of f at t at x equals 7. Kabam! Negative 8.11, well, I could say 119, or I could say 120. Let's think about what the units should be. When you take the derivative of a function, you are finding the rate of change of that function. But f at t is already a rate. F at t is the rate at which packages are being removed from the display in packages per hour. So if we take the rate of change of that rate, then we're talking about packages per hour per hour. Instead of saying packages per hour, you could also say packages per hour squared. In context, this means that 7 hours after the store opens, the rate at which packages are removed is decreasing at a rate of 8.120 packages per hour per hour. Number 3, is the number of packages of toilet paper on the shelves increasing or decreasing at time t equals 5 hours? Give a reason for your answer. Anytime we need to figure out if an amount is increasing or decreasing, we just need to compare the rate in to the rate out. If the rate in is greater than the rate out, then the amount will be increasing. If the rate in is less than the rate out, then the amount will be decreasing. In this scenario, the rate in is represented by G at T. That's the rate at which employees are putting packages on the shelves. The rate out is represented by F at T. That's the rate at which packages are being removed from the shelves by customers. We are being asked whether the number of packages of toilet paper is increasing or decreasing at time t equals 5 hours. So our strategy will be, let's find the rate in at t equals 5, and let's find the rate out at t equals 5, and see which one is bigger. We already typed f of t, the rate out, into the calculator as y2. Let's type the rate in, g of t, as y1. So we go back to the calculator and we hit y equals, and we are going to type this expression into y1. So here we have the rate in typed into y1 and the rate out typed into y2. To evaluate these, we will ultimately use the table feature up there above the graph button. But first, I need you to make one adjustment. Hit second window to access the table setup menu. Scroll down, and I want you to change the independent option from auto to ask. Once you've done that, go ahead and hit second graph to access the table menu. Remember that the rate in is typed into y1, that's g of t. The rate out is typed into y2, that's f of t. We can evaluate both of them at time t equals 5 by simply typing in the number 5 and hitting enter. So we have found that at time t equals 5 hours, the rate in is 11.533 packages per hour, while the rate out is 13.796 packages per hour. So basically, because the rate in is less than the rate out, that means the number of packages is decreasing. But we have to be a little bit more specific than that for our final answer. The number of packages on the shelf is decreasing at t equals 5 hours because g at 5 is less than f at 5. By the way, it is very necessary that you state what g at 5 is and what f at 5 is. Don't just say that g at 5 is less than f at 5 without showing why you know that that is true. Number 4. How many packages of toilet paper are on the shelves at time t equals 8? Be careful. Packages are being removed the entire time, from t equals 0 to t equals 12. However, packages are only being added starting at t equals 3. Here is the basic idea. The number of packages on the shelf at time t equals 8 should equal the initial number of packages at time t equals 0 plus the number of packages that were added during this time frame minus the number of packages that were removed during this time frame. Notice that when I talk about the number of packages that are being added, I say from time t equals 3 to t equals 8. That's because packages were only being added during this time interval. But when I talk about packages being removed, I do t equals 0 to t equals 8 because packages are being removed the entire time. Let's write an expression for each one of these three things. We know that when the store opens, there are 50 packs of toilet paper on the shelves. So the number of packages at time t equals 0 is 50. The amount is always the integral of the rate. So the number of packages added will be the integral of the rate in. In other words, the integral of g of t dt from 3 to 8. And then we must subtract the number of packages out during this time interval. And again, the number of packages will be the integral of the rate of change. So the number of packages out will be the integral of the rate out, which is f at t, from 0 to 8. This is something that can be typed into the calculator. So we can type 50 plus. Next we need the integral from 3 to 8. So we hit math and 9, and we're going from 3 to 8. Now we're doing the integral of the rate in, which we typed into y1. So we will hit vars, yvars, function, and y1. And go ahead and put this dx. Now we must subtract the integral of the rate out. So for the integral, again, we do math 9. This time we're going from 0 to 8. And we're doing the integral of the rate out, which was f at t, which we typed into y2. So for y2, we do vars, yvars, function, and y2. And then just finish that off with a dx, and kabam! 23.347. Rounding to the nearest whole number, that's 23 packages. Number 5. Find the following below. Then explain the meaning of the expression with the units in the context of this problem. What is 1/2 of the integral from 0 to 2 of f at t dt? We can just type this into our calculator, but remember that f at t is typed into y2. So here we go, 1/2 times the integral from 0 to 2. So we type 1/2 times the integral, so math 9, from 0 to 2. And then we want f at t, which is in y2. So hit the vars button, switch to yvars, hit enter, and choose y2. And then finish it off with a dx. 10.026. What about the units? We know that the integral of a rate is going to be an amount. So this will be some number of packages. So now we need to explain the meaning of this expression in the context of the problem. So what is the point of the 1/2 that's out in the front of here? Do you remember the formula for the average value of f at t on the interval from a to b? It was the integral of f at t from a to b divided by the interval b minus a. So the average value of f of t on the interval from 0 to 2 would be the integral of f of t from 0 to 2 divided by the interval 2 minus 0. Well, 2 minus 0 is just 2, and dividing by 2 is the same thing as multiplying by 1/2. So what we're looking at here is the average value of f of t. Actually, my units are wrong because this is the average value of f at t. And f of t is the rate at which packages are removed from the shelf. So we're talking about the average value of this rate, which is in packages per hour. So the average rate at which packages are removed during the interval from 0 to 2 hours is 10.026 packages per hour. Number 6. Write but do not solve an equation that when solved for Q would represent the time when there are no more packages of toilet paper on the shelves. So I guess the big idea would be that the initial number of packages plus the number of packages added minus the number of packages removed should equal 0 at time t equals Q. So we know that the initial number of packages was 50. For the number of packages added, we're going to have to add an expression involving the integral of g of t, because that is the rate at which packages are added. Don't forget, packages are only added starting at t equals 3. So we will integrate from 3 to Q, the mystery time. Packages removed, we will subtract, and this time we will integrate using f of t, which is the rate at which packages are removed. Packages are removed the entire time, so we will integrate from 0 to Q. And this should all equal 0. Select values of function f. The rate customers remove packages of toilet paper from the shelf is listed below. The function f is differentiable for all values of t. Number 7. Does there have to be a time t on the interval from 0 to 12 at which customers are taking 4 packages of toilet paper per hour off the shelf? Justify your answer. It sounds like we will need the intermediate value theorem, which says that if f is continuous on the closed interval from a to b, and if f at a is less than k, which is less than f at b, there is a c on the closed interval from a to b, where f at c is equal to k. But wait a minute. In order to use the intermediate value theorem, we have to know that f is continuous. In the setup, we are told that the function f is differentiable, but we are not told that it is continuous. If a function is differentiable, it is automatically continuous, but we must add this statement right at the beginning to confirm this. F is differentiable, so f is continuous. Now we can use the intermediate value theorem. Look for a time when f at t is less than 4 packages per hour. Well, time 12 is such a time. Now look for a time when f at t is greater than 4 packages per hour. Well, all of these times f at t is greater than 4 packages per hour. I'm going to go with time 0, just so we can go ahead and use the interval from 0 to 12. Since f at 0 is greater than 4, which is greater than f at 12, there is a t on the interval from 0 to 12, where f at t is equal to 4 packages per hour. This is the intermediate value theorem at work, but we can make this statement without actually naming the intermediate value theorem. Remember, the fact that f is continuous is a prerequisite for using the intermediate value theorem. So you must say f is differentiable, so f is continuous, to get full credit.